Hello, this is Dan Groninger for GE Inspection Technologies, and welcome back to our series of instructional videos on the Mentor EM eddy current instrument. In this installment, we're going to take a look at tubing inspection, and we're also going to take a look at a feature of eddy current instruments that's commonly used in tubing, and that is mix. So in mix, we take readings with one probe at multiple frequencies simultaneously, and what we will do is tell the instrument to ignore certain kinds of indications from the probe because we know what they are. So that's what we want to do. In a boiler, if we're doing a boiler inspection and we have our boiler tube, and the tube is mounted in the boiler in a grid plate, we'll have tube supports periodically along the tube. Now our eddy current bobbin probe, some of the field will extend all the way through the diameter of the tube, and it will be impacted. We will see the steel plate that the tube is mounted in. And we're not really interested in that, but if there happens to be cracks right at the edges of the tubes, we'd really like to see the cracks, but we're not all that interested in an indication from the plate itself. So what we're going to do is, as we move the probe through the tube, we're going to look at two different frequencies. At a higher frequency that's going to be more sensitive to defects on the ID of the tube or in the tube wall itself. And some of the field from that frequency will still make it out to the tube plate and we'll still see the indication. We'll also look at a much lower frequency that's less sensitive to the defects in the tube itself, but will be even more impacted by the tube support plate. And as we get through our calibration process, we will show that indication to the instrument and say, I want you to calculate how to make the two frequencies, the signals from the two frequencies under this plate, look as much as possible the same, and then subtract the two frequencies and give me a third channel that's the result of that subtraction. Okay, so I'll fire up our tubing app. And in older eddy current instruments, the entire process of making the signals from the two frequencies look as much alike as possible fell to the operator. So as the operator went through this process, he would have to look at the signal from his lower frequency and adjust the phase and the gain until the indication from this tube plate looked as much as possible identical to the primary frequency that he was using for inspection. And if he did all of that just right, and got all of his adjustments tweaked in just right, you get a minimal signal from the tube plate and still see good signal from the flaws. Now in this tubing sample, I have 3 flaws built into the tube. I have a hole that goes all the way through the tube, one that goes halfway through, and a set that go only a quarter of the way through the wall. And we'll see the difference in those as phase separation on the screen. So what I'm going to do is balance, and that clears my signal. I'm going to pull the probe slowly through the tube, and what we got there, I'll let that run for a second. So what we have is the green is our primary frequency, a higher frequency, in this case 380 kilohertz. The blue trace is our subtract frequency, or the lower frequency that we want to look to plate. I'm going to freeze that. That's the lower frequency that I want to penetrate well and see the plate. And there's a magenta, or a hot purple color, that will show us the result of the mix. And we haven't calibrated yet, so the mix is way off screen at this point. Now, if you recall in our earlier videos, we talked about how to use the analysis tools in the strip chart to put down cursors to look at areas of interest in time. And you notice I have my strip charts oriented vertically here. Behave just the same way as they did before. I can move my traces around by swiping my finger. I can actually move my finger on any of the strip chart views and it updates the cursors on the active view that I have open. And I can stretch that out so I'm seeing just the indication that I'm interested in. And if you notice, I've got the indication. I had 3 indications from the flaws, and I have 1 indication from the tube support plate. So I have, let me show a little bit more here. So there's my tube support plate. That is the flaw that goes, stretch it out just a bit. That's the flaw that goes 1/4 of the way through the wall of the tube. There's the flaw that goes halfway through the wall of the tube. And there's the flaw that goes all the way through the wall of the tube. So all the way through is at about 40 degrees angle. Halfway through is vertical. And 1/4 of the way through is about 45 degrees laid off to the right. And you notice the phase separation is much less on the low frequency as compared to the high frequency. So if I squeeze these together so I see all 3 indications at one time, there we go. So there's the 3 flaw indications. You see I have nice phase separation on the prime frequency, much less phase separation on the subtract. Now if I zoom back out, and we look at the indication from this ring, you notice I've got a lot of phase separation, and I'm getting a much larger indication from my subtract channel, my low frequency, because the field's penetrating the walls of the tube much better. Now at this point, I've acquired the data, I've pointed the instrument to the area of the buffer that comes from the tube support plate. You know, I've got that indication up on the screen. And now at this point on an older instrument, I'd start working with the phase and gain to try to make this one look as much like that one, and the mix would be showing me the result of that. On the Mentor, all I need to do, once I've selected that, is hit Calibrate, and it goes and calculates a 4-factor mix. So in addition to phase and gain, it applies what we call squish factors until this looks almost identical to that, does the subtraction, and what I'm left with is a little bit of noise from the signal. So there's all that's left of the indications from this support ring. Now you say, what happened to our flaws? All right, let's walk back in time. There is the flaw that goes 1/4 of the way through. So we get a signal that looks very much like the prime. There's the halfway signal. All right, so we're a little bit phase shifted. We have a little bit of change, but still a very recognizable flaw. And there is the hole that goes all the way through. So now I can see my flaws very nicely. All my flaws show up, but the tube support plate, not so much. If I further compress this to show all 3 flaws and the support plate together, you notice I have some very large indications from the support plate that could make it difficult to gate on actual defects. Okay, so now let's go back to live mode. And we'll go down to clean end of our tube. We'll clear, pull through, defect 1, defect 2, defect 3, tube support plate. Okay, now let's take our tube support plate and put it right over top of one of the defects. So as we go back through, there's the defect. There's the 3 defects. So defect 1, defect 2, and here's the one with the tube support plate. And you notice our response from the primary and the subtract channels are somewhat obscured by the tube plate. But if you notice the mix channel, The indication from the tube plate is gone, but we still have a very neat flaw. I can put the flaw right at the edge of the tube support plate. And still, clean flaw. You see a little bit of change of shape of the signal, but not appreciable, and you can still gate on that quite well. Take our plate and put an edge right over the through hole. This way. There you go. Okay, so that's all there was to mix. So just to recap, we hold our probe through and past all the targets. We froze. Come in here, put a cursor down and selected just the thing that we wanted to get rid of, that big tube support plate. We hit calibrate. The system calculated what we wanted done. Then we went back to live run. Flaw, 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 tube plate, and we popped out of the tube there at the end. But that's how simple it is to set up a 2-frequency mix on the Mentor EM. Very quick, very easy, and very effective with the 4-factor mix calculation. All taken care of for you. So thank you for joining me today. Again, I'm Dan Groninger for GE Inspection Technologies.